Welcome to the 2025 Future Networks World Forum INGR presentation session. Right now, we'll present the 2025 edition of the International Network Generations Roadmap, the Artificial Intelligence and Machine Learning AI/ML chapter. My name is Bao Cheng. I'm the co-chair of this AI/ML working group, and I'll be presenting this chapter on behalf of the working group. The AI/ML part of the Future Networks technical community. There's a URL on the webpage and a QR take you to the working group webpage should that interest you. Primarily, this working group provides a roadmap based on research and industry advancements to deliver the AI for the networks of the future. We care about AI and machine learning as they relate to networking and telecommunications. We care about architectures and frameworks that support AI and ML workloads for different domains. And most importantly, we anticipate AI and ML challenges and developments over multi-year horizons. As a working group, other than creating this roadmap, we also do other things like organizing webinars, doing industry outreach, supporting conferences, forums, etc., etc. On average, we host one webinar per month on average. Topic is usually focused on the intersection that is AI, ML, and networking and communications. Many of our webinars are also co-hosted and co-sponsored in a section. And anyone that has an interest in joining the AI/ML working group, please feel free to write to the email address shown on screen here. That will bring you to all the co-chairs in the working group. Okay, an outline for the AI and ML chapter. So first, contributors, so framing and alignment, how we align with 6G and IMT 2030, and then the chapter outline itself, and end with recommendations that is in the 2025 edition. Okay, so all our co-authors, we have, I think, 14 or 15 of them spread all over the world. To also serve as the editor for this document. I also thank our external reviewers, all our authors, and our professional support staff as well. Now, in terms of thematic framing, the focus for our 2024 and 2025 chapter is the commingling of AI/ML and the network, and how to make the network itself intelligent. I mean, you can think of, in terms of relationships between AI/ML and the network, and think of how one would adapt the network to support the AI/ML workloads, or how to use AI/ML to improve the network. But for our 2024 and 2025 editions, our focus is on the commingling of both, and to make the network itself intelligence. Now, in terms of how we align with 6G and IMT 2030, shown here, two images frequently cited from the IMT 2030 document, the user scenarios, as well as the new and enhanced capabilities. You see yellow stars being marked on those pictures. The yellow stars mark the areas where the 2024 and 2025 edition addresses certain scenarios or capabilities. Okay. So it shows you at a quick glance how we align with 6G and IMT 2030, 25 edition. Now, for the chapter itself, yes, we focus on the commingling of AI, ML, and networking to make the network intelligent. We've mentioned that before. We also recognize the 6G and IMT 2020 vision, and how AI, ML innovations introduced, and we talk about AI and ML innovations introduced circa 2023 and 24. We explore new potential capabilities that are enabled, and new questions that are inspired thereof, and we contemplate what it means to have intelligence in the network and what else can be done with it. The key topics we address include AI/ML-defined radio, integrated sensing and communications, reconfigurable intelligence surfaces, generative AI for prediction-based networking, systems analytics, dynamic digital twins, dynamic data-driven application systems, DDDAS, and expansive vision on next-generation AI for next-generation wireless networks. So in there, we present an expansive vision that seeks to incorporate large concepts like artificial general intelligence, the telecom brain, reasoning that recognizes causality, distributed collective intelligence, semantic communications, distributed and universal foundation models, etc., into the wireless networks. Now, I do have many that talk to each of those topics, but given the time constraint, I will not be going through every one of those slides, but we'll just flip through them to the point where we get to the final recommendation in the chapter. Since this is recorded, flipping through the slides we'll give you a chance to pause and look at slides individually should that interest you later on. Okay, so final recommendation coming out of the chapter, we recommend going from AI native to AGI, the G for general, artificial general intelligence native. We want to endow network systems with cognitive capabilities. We want to encourage autonomous operations with minimal human interaction, zero-touch networks. We recommend integrating semantics into Open RAN, so integrate future wireless technologies such as semantic communications without radically changing the 3GPP layered network architecture, and create a semantic brain module that has a dedicated interface with all the OSI layers. We also recommend distributed universal foundation models. We will want to embrace distributed universal models, endowed with causal reasoning and neuro-symbolic AI properties, and foster collective intelligence via distributed training and inference models. So that's the recommendation coming out of the 2025 edition of the chapter. And with that, I thank you for your attention. And please hold off all questions to the end where we have a Q&A session with the expert panel. And with this, I will pause this presentation and switch to the next chapter. Prakash, do you want to go next?
I can put it. It's fine. It's working.
Yes.
Or I left.
Yeah, I can drive the slide. You can just speak to.
Yeah. So
No, yes, this is the yes.
Hi everyone. Can you hear me? Oh. Okay. Now? No. Huh? You can hear. No, not to the mic. Not to the speaker. Okay.
Testing. Speak this direction.
Testing. Yeah.
The Edge services first or the QID
Edge.
first? Edge first. All right, Edge. I need to re-trigger the sharing function. Sorry about that. Edge. Okay, it's a PDF file, so give me 1 second.
Just begin.
Yes. Good to go.
Hi, Prakash here. Services and Platform Working Group, which is led by TK Lala, and we are coaches. So the first thing about the edge services, it has been there for quite a bit. So if you look from the next slide, if you look from the charter point of view, this is a multi-year technology development and evolution roadmap for edge-centric computing and services. Obviously, it is influenced by the computing and network technologies, and several use cases are there. What we have done so far is in 2021, we published one, 22, 23, updated in 24, and this is for the 25th, 2025 update. So we had started edge and then edge spread out. Edge's horizon is always misleading. It's like a micro edge services, so we don't know. Because focus more on the smart city IoT. But later on, moved on, and as it moved on, we have updated it continuously. And it is given the legacy we have for more than 6 years, having established, it takes a little bit time more to update. But what we have is next generation, what is happening in 2025 and future. So based on that, what the coaches have decided is that we should focus this year mainly on the AI/ML. So next slide. So what you see is this AI is recognized as the main driver for most of the infrastructure. Edge infrastructure is also driven accordingly. And you can see that you can have peer-to-peer, you can have level playing field with the existing legacy data center, etc. Incentive-based crowd resource network and resource edge nodes are the current themes. And non-terrestrial is also being accommodated to make the edge closer to the what you call moving objects. So that's why mobile edge also comes in there. And edge platform are node scope. So it can be for the home nodes, it can be for business, it can be for enterprise, it can be for industrial and large levels. So you find that next slide. So the focus has been AI to those areas. So in this, what we are showing is a hardware technology influence on the edge platform, and hardware technology, especially the current market driver is NVIDIA, and they have computer unified device architecture called CUDA, and AMD has ROCm, which is nothing but Radon Open Computing. So these two are the main foundation development tools for the hardware-centric influence on the edge. And others are based on the models. Of course, there is a models and systems, two areas which dominate in this. So AI models like inferencing model, training model, inferencing. Inferencing is the key because training is generally done in the cloud mostly, but inferencing is where it is driven. And inferencing driven, then you get into the large language models, and there are many of them. So issue is what will stick depends on what domains you are using and what is the skill set level of the people who use it. And so we definitely have tried to cover as many as we can. And general multimedia also enters beside the text. Next slide.
So as for the whole lot of confusion.
So what we have is AI networking technology. So 5G to 6G migration, that is the current theme of as a INGR, and it includes the terabit network, InfiniBand from NVIDIA, Wi-Fi 7 and beyond, and non-terrestrial networks, etc. So DOGO, NEO, etc. So coexistence of all this is important, and we are trying to adopt to make sure that we also include the cognitive security and QKD in this. Next slide. So AI-centric smart resource management is more optimization towards optimization, and try to use the underutilized capacity where available, anticipate and be proactive and adaptive cognitive security, etc. So resiliency, fault tolerance, and minimum downtime of this edge infrastructure, in general, most of the infrastructure. So near real time currently is in the order of 5 millisecond, under 5 millisecond, because it's not just everything is real time. So you expect that low latency and main driver will be low latency and obviously the real time, which can be adopted. So as they evolve journey, and therefore we continue this in our pursuit, and that's all I have from our side for the edge services and platform working. Thank you very much. I can move on to the next one.
Yes, the QIT.
Yes, QIT.
Okay, let's open up the QIT slide and we'll get going. Okay, we'll go.
Welcome. This portion, this is Prakash Ramchandran again, and this I am focusing on the FNWF 2025, since we are on the INGR side of it. Let INGR QIT work. So I have co-chair Chintan, myself, I am here. You can read about it later. And then I have been leading this from inception, and my co-chair has been Chintan Oza. Both of us have started these efforts before I get into the entire thing, because we missed the portion of the recording earlier. I would just say that INGR is structured into 15 working groups. So we have got the user access focused, some of the groups like satellite, deploy, connecting the unconnected, edge services, edge services. These are all focused on user access. Whereas network and computational performance, these are held by the MIMO, system optimization, millimeter. There are renamed like megahertz and all that. And quantum information technology is one, which is introduced earlier, which is what I am representing now. There are system standards like standard building blocks, testbed, energy efficiency and all. And the last one, service enablers or security application services. and AI/ML, which took the first spot and presented. So moving on to the next slide, the quantum information technology working group was proposed and formed on September 30 and approved in 2023. The first 2 years, our vision is not changing. Vision is all same. We want to make sure that quantum information technology in 10 years is able to provide a workstation, kind of a quantum workstation on your laptop. That would be the dream vision. Scope is, of course, covering a couple of areas: computation, communication, and sensing and control. So with that, I will go to the next slide. So accomplishments and challenges. So the phase 1 we completed on September 2025. So what we did was, we have got a QIT roadmap document edition 1. We have got the technical, 2 of them on the Willow, which is the GPU cluster from what do you call Google. Then second, so obviously we do have clusters with QPU, GPU, all combination. And what are the applications? So myself and Chintan knocked out the second publication, which has all the relations to what kind of applications we can host it for. The third, 20, in the QIT members, we started around 20 research papers we have peer reviewed for the INGR. Plus we have major, and I must thank Bob for his initiative. We have completed QML, PQC, QKD, QEI, RAQR, system of for LLM, etc. So AI/ML and QML group have quantum IT group have been working together. Then the participation in IEEE, we started with Seattle. Yeah, and then we have doubled. We have currently completed 3 events. In the phase 2 challenge, what we are going to do is double our updates release in 2 years, in 2027. We will take publications, one special quantum issue we want to bring, and then invite research papers for 2026 for the, and add 1 more workshop in 2026 and participate in IEEE quantum. Next slide. And I think I am going to just wind up, since this is already covered. The major moving towards the phase 2 for us is to, how do we align with goals of 6G and beyond, AMC 2030. So here the quantum information adds to all the excess that we want, 10x to 300x, depending on whether it's energy, etc. So the main theme, next slide, you can see that the main coverage that I have done. Next slide. Yeah. So what we have is, now we are focusing on quantum computing for utility, fault tolerant scaling, and twins. On the quantum computation side, we are trying towards personalized PNT, we call positioning, navigation, and tracking, which we want to bring the accuracy. And the sensing, of course, we are looking at a potential RAQR, which was presented by one of the presenters in the webinar from Indian, from the Singapore University. So those are the 3. Next slide. So what you can see is the picture tells half the story. So RAQR, RAQR is showing here. Quantum QML is showing up there. So everything. So the 3 areas, as I said, they are the ones. Next slide. So 3 areas we are doing is quantum integrated sensing, quantum integrated networking, and quantum integrated computing. And all these 3 have specific areas and specific KPIs which we have evolved. And based on that, we are taking the direction in 4 directions, including the non-terrestrial, which is going towards the satellite for the using of quantum. And there are challenges, and NISC era is ending. We have to get into fault tolerant, and quantum, what do you call, the benchmarking initiative from the DRD and DARPA is one, which is the hard first, I will go through it. And Leo, Mio, Geo, etc., and other critical computational work along with AI will enable us to do what we need to do in the coming years. And with that, I will end the quantum information technology work with readout plus the readouts we did for combinations of the. Thank you.
Thank you very much, Prakash. Okay, next working group, next chapter we have. Do we have anyone from the Connecting the Unconnected chapter? No? Okay. How about Testbed? Anyone from Testbed? You want to go next? Okay, I'll pull up your slides and feel free to use this microphone. You can just signal me when you say next slide. Yeah.
Okay.
5 minutes.
5 minutes?
5 minutes.
Okay, great. Sorry. Right, yeah. Morning, everyone. My name is Amit Shohet. I'm the contributor to the INGR. And I'm here to talk about the 2025 update, which is the 4th edition of INGR chapter. Yeah,
I apologize. The voice doesn't come very clear. Maybe you can speak closer to the microphone, please.
Okay.
It's a directional microphone. You have to speak like to the top of the microphone.
Yeah, very good. Okay, hope it's very clear now.
Better.
Okay, great. So can you move Bob to the second? Okay. So as I said, like I'm one of the contributors for this INGR Testbed chapter, and we've been working for the last couple of years. I mean, I've been part of 2024 update as well as 2025, and I'm going to introduce about next. We have introduced 3 pillars to this testbed thing. The main pillars are about what is going to be in this 2025 edition is about ISAC integration, and then the quantum networking and the native protocol stack. I'm going to deep dive into one by one as we move along. And just to give you a summary, like what has been done part of 3rd edition and how did that played a major role to have a 2025 update. So that is the whole idea about the overview of this slide. About next. Yeah, as you all may be aware, like what is ISAC? ISAC is nothing but it's one of the cornerstones. And what does it do? It's not only communicate data signals, it will also sense the environment. It has to know what is happening around it. So it is doing 2 jobs at the same time. One is data network, another is sensing its environment. So an example could be like, a connected car, for example. What is a connected car? Connected car doesn't, car has to talk to each other, right? That's data. And also it has to adapt itself to know what is its surroundings, what is the obstacle, how far is the obstacle. All these are called sensing. It should be aware of its own surroundings. That is what is an example what is ISAC is all about. It will be one waveform tomorrow. And this waveform will support not only connectivity, it is also will make the awareness of that particular device, or for example, the connected car here. Yeah. Next slide, please. Yeah, quantum networking. The other major pillar is quantum networking. This is all about the intrusion. How do you avoid it? For government agencies or some financial institutions, they don't want people to intercept, right? There should not be any communication that should be so fragile that anyone can intercept it. It should not be in such a way. So QKD is one of that secure. It will make the connectivity so secure. It is by means of this using this encryption algorithm, which is called QKD. So this is one of the major pillars we have introduced. I mean, which will be part of 2025 edition. And I just gave you an example about the financial institution, how QKD can be employed there, and so that we can secure the communication over there, so that no eavesdropping can happen towards that network. Yeah, next slide, please. And yeah, so now AA native protocols. Now talking about 6G, 6G AA is not only on the application layer. It should be part of the core. This is one of the important aspects of 6G itself, right? So it is not an application layer anymore. node. It is a core of the 6G network. We have to bake it ground up, build protocols. It's not only about what is happening around it. It should make sure that it detects on its own, take the decision on its own based on the intent. That is one of the major, the protocol is one of the major pillars. Again, we have to be part of 2025. Yes, go next, please. Yeah. So, what is about
1 minute.
Sorry?
1 minute.
1 minute more. Sorry. I thought you took the meeting. Something. Okay. So, yeah. So, what are those, roadmap is all about, right? Roadmap is all about, we're going to give a metric for each year, like what is going to happen in this year and what is the forecast. So since the time is less, I'm going to just focus on the current metric. So today ISAC is predicted around 2. It can make sure that it gets in surrounding by 20 centimeters. Moving on, 2020. So again, next please. And QKD is how fast that QKD can be done. I mean, this encryption algorithm can be generated. Today it's in kilobytes. Moving on, it will be that. So next slide, please. Yeah, and then the 2025, as we see in 5G, this application AI is in the application layer. Moving on, what we expect is it has to be built at the core. It should be the brain of the entire 6G network. Okay, so that's it. Thank you so much. Yeah, thank you.
Great.
On the dot.
Thank you very much. Thank you very much. Would security and privacy like to go next, Mr. Ashutosh? Okay. Use this microphone. I will, I will pull up your slides. Give me 1 second. Yeah, that's all right. You just tell me, next slide, I'll move it.
Okay, can you hear now? Okay, because big screen, right? All right, well, so when is getting this, I must close that the security worker co-chair. Johns Hopkins and Dr. Group co-chair and say the professor at Texas A&M University. So we'll be giving a little brief about security privacy working group that's been going on for the last 6-7 years. Next slide. Things happening in the world, right? A lot of attacks you might be seeing, and with AI ML coming, you can see some of the things we are showing. There is a
The
challenge
voice comes
and
intermittent.
so we need to make sure we have enough talents also. So skill set development is important while we try to find out what are the problems, how we can fix it. So this slide talks about that. We go to the next one. So security by design. So here we are talking about what is happening in 6G and what were the problems in previous generation like 3G, 4G, 5G fixed a lot of problems, but there are still some problems with 5G. I used to be at AT&T Chief Security Office. I've seen how things do bad things. So we have to, they call it defense by design, right? So we have to make sure any roadmap we are doing, we think about 5-10 years from now, what kind of a come and how do we take care of that? So there are challenges and opportunities. That means the new features, we can take advantage of those opportunities to make the security stronger, but at the same time, there are also challenges. So we have to make sure we have enough tools, secret monitoring tools to fix those, right? Then in order to do that, you need to have a systematic approach, right? You look at the types of, come up with a threat taxonomy, come up with a mitigation control, and do some proof of concept to make sure they actually work. So in the security working group, we are doing all of those, not only just writing papers, we are also doing a lot of experimental work. Next. All right, so there are 2 types of contribution we are doing. One is obviously technical, where we are inviting people to contribute their ideas. Again, this is all open, neutral, and look up the risk scenarios per taxonomy. On the right hand side, we are also trying to see how we can disseminate. It's just not developing and keeping it. We like to have the security workshop, webinar, seminar, things like that, INGR read out. So those are 2 ways we are trying to propagate what's happening in the working group. Right. So what is the addition chapter? So 3-year, 5-year, 10-year roadmap. Use cases, we have started looking into use cases, AI, ML security, privacy and efficiency, blockchain. These are some of the taxonomy security domains, systematic security assessment models, Again, I'll give one or two examples if I have time. Security standards opportunities, how do we work with other working groups, and see, because every pillar, they need security, right? So we have to embed ourselves. We talk to AIM, talk to satellite, talk to application, and see how some of those can be embedded in there. Then linkage to the key stakeholders who are going to be using end users. Challenges and plus potential solution. Next. We started looking into that 6G exposed PGPP, and these are some of the things we are adding for 2025. Physical security, interoperability, network access control, NT security, which is ubiquitous connectivity. So we are handing over how do you make sure the security is still maintained from Wi-Fi to satellite to cellular. Control in user plane security, zero trust in various layers, security monitoring, threat detection, mitigation, requires sidling security. These are high level, and we are focused on each of those. Next slide. Yeah. So if you see the challenges in operation security, challenges in operation, so we say security, there are risks to succeed, and there are also enable opportunities. So we should figure out what are the opportunities, and the challenges side, it could be device, challenge on the device side, could be network side, could be application side. So we have to look at the whole end-to-end ecosystem to figure out what are the challenges, right? All right. So this is slide, very important slide. So if you see, these are different pillars. And of 5G, 4G, 5G, or 6G, software-defined network, open source API, AIML, slicing, virtualization, orchestration, quantum, we just had to talk about that, supply chain is cloud. So these are the pillars have 6G more feature enable, right? That means it will be flexible, resilient, etc., etc. But at the same time, we are looking into the challenge that comes with software-defined network, or virtualization orchestration. So our roadmap talks about all of them. That is, your system should be right?
Yep. Yeah, 1 minute left.
Yeah, so this is a framework. We are doing closed loop framework. You see the AI agent. We are putting the AI agent in each of those security function. How the AI agent communication can be secured. That's something we can collaborate with AI and folks. Just to give the framework. Next slide. We are looking at different kinds of measures of cyber denial of service, degradation, manipulation, data exploitation, and we are applying some of these different use cases. Maybe in the next few slides. We're looking at the risk associated with each of these, right? Right. So just keep on here. These are different kinds of threats that are coming. We're looking at the whole end-to-end ecosystem. This is just an example of mobile edge alarm system. Next slide. So these are the opportunities, challenges, education, and security. So this is how we are doing all of those things, right? So yeah. Go to the next slide. Attacks on the control plane. Next slide. User plane. Yeah. These are the use cases we are doing. So as I said, the last piece, proof of concept, right? The control plane attacks, user plane attacks, C-based denial of service attacks, HTTP-based attacks, because these are all API and services are detected. These are pivoting attack, signature-based identity-based access control. So these are different use cases we are doing. And then I think I don't have time to go for that. There are all lots of modules we're adding. Yeah, so these are different modules we have tried. How do you framework and look at the attacks and stop the attacks? So these are all going to be in the 2025 program. We can just pass forward. Yeah. Sorry. Yeah. So these are the tools from the looking at this again, new addition with AI ML becoming an important field of C. We are looking into some of the security risks and opportunities for AI. So summary is, as I said, you got an idea about, we are just not really looking at taxonomy. We're also trying to see how we can do some concept in the lab and what the Department of Homeland Security get some input. I personally work, Emmanuel's work, and we ask all the people in the world around the world if they have some use case, they can do that and do proof of concept. I think important part is the collaboration, vendors, regulators, academia, standard, testbed, people concepts. So this has to be part of the ecosystem. Thank you.
Right, thank you very much. Thank you very much. I think next, Sudhir, are you ready to present the Connected chapter? All right. Yes. Okay, next we'll go to connecting the unconnected. Use a microphone. And 5 minutes. I'll let you know when you have 1 minute left.
How much time do you have?
5 minutes.
Okay, so,
Like this.
It's directional. You have to speak directly to the top of it.
Like singers.
yeah, okay. Right, so, I mean, I think this particular topic does a partly in introduction. So I go to the content of this particular steps about 5 minutes. Usually it was funded by the also gave rise to connecting the unconnected global challenge. Can you hold it like this? Hold it like this.
No,
Stay.
not like this, like this.
Hold,
Yeah.
like this.
That's what I'm saying.
Okay. So, this is the outline, but I'll have to walk through it very quickly. Table of contents of chapter, we have published 3 editions of this particular chapter. The 4th one was to come out at the end of last year, but I think we were decided to release one chapter every 2 years. So the next issue is going to be coming out sometime in the start of the year. This is a divide overview. I want to spend time on it to subject. What are some of the challenges for connecting the unconnected? So, I'll go through some of the work that's been involved in INGR. And that's about this completion of the summit. The summit that's already happening tomorrow here. And the award winners for the company. Tomorrow as well. Next one. I won't go into it, but this is the flavor of the chapter. You have the scope of the working group, what they are doing, who are working with. Connecting the networks. These are some of the solutions that look at and in this chapter. Shares access. And what the future state will be in about 2029. And it's 10 years from the time the company. And the answer question upon the notion of free access to internet. A lot of work done at the United Nations. We should find the term called digital public goods. That's mostly refers to the content. Similar to the terminology that is being used in India and other parts of the world, digital public infrastructure. So there is a bit of a difference here. Digital public goods basically means the content that people can access and view free of cost. And that is content that has been approved by the government or some body, which is of most use, healthcare, government services, safety, security, digital economy, banking, and things like that. So if you're accessing that kind of content, that is not the charge against your data plans that you have subscribed from your mobile operator. Go to the next one.
1 minute left.
Okay, maybe then I won't go beyond the table of content. He also spent good amount of time coming out with the next edition on what is the role of AI and ML
A lot of people have been taking their AI, ML, cloud, and all those are for the Android space, for consumer services and all those things, like something like that. But application also because that takes away not the complexity of usage or accessing these services by the users. So it's like a profile gathering or things the personalized for ourselves, how to upload the user interface and make it nice and and that is security and privacy. So we have to the last edition spent a good amount of time on use of AI ML. And that has a lot of application culture. For example, like drone technology for fertilization, for looking at what the issues are in the crops, what kind of pesticides to provide, and so on and so forth. Where the nearest markets are, where to sell the produce, so that the farmer will get the best price, and so on and so forth. And we have also touched upon the cost optimized network architecture. The biggest challenge, as we all know, is the backhaul. It's not the local coverage. A backhaul is not easily available, or it is the most expensive thing. Then there is a definition of last mile, middle mile, network, and backhaul. We look at the technologies of the line of sight backhaul solutions and non-line of sight, which are backhaul solutions. And we have looked into intelligent reflective service around and so on and so forth. So it is has been an interesting work to look at all these different technologies and what their rules are. Because there is not one solution that fits all. A different solution can be fit for in different scenarios. In the area, flat land, and whether there is fiber going to the nearest community and so on. And human-computer interaction is something not talked a lot about. But as everybody says, so many things are like as a service. When we have computer interaction as a service. So when you are running an app, everybody gets the same UI. But can we have an UI that is residing in the cloud and that is and the kind of UI that matches with your digital capability? So because really it's a big challenge for the rural areas, they are not that savvy. And they are very vulnerable also for attacks and for fraud and all that. So there are different kind of challenges for when it comes to security and privacy. Password-based security mechanisms are not going to well. So very good government mechanisms that are provide security to the people. We also look at the sustainable business model, different kind of business models, not the one that mobile operators are. Yes, that meaning having lightweight regulations when it comes to security and power that can be transmitted, allowing the micro entrepreneur put the infrastructure in the village and we have to offer the same infrastructure to working service providers as an overlay. Because a micro entrepreneur will be happy with maybe 20-30% ROI or 10%, whereas a big operator would like to get significantly much more ROI. So we go into all those kind of things in this chapter and welcome to all download the paper. And thank you very much.
Thank you very much, Sudhir. Thank you very much. Thank you. That concludes the presentation for the Connecting the Unconnected chapter. The remaining chapter that we have will be presented used through pre-recorded video.
Hi, my name is Narendra Mangra. I'm the Applications and Services Working Group Co-Chair, and today I will be discussing the 2025 edition and some of the information that you can find or expect to find on when you download a copy. I'm involved in a number of IEEE activities, as you can see below, and I'll be speaking today about the roadmap development perspective. So In the IEEE FNTC roadmap development group, such as INGR, we have a number of working groups that are looking at different areas of interest. The applications and service group is shown over on the upper right-hand side. And there are two standards that came out of the working group in general. There's the Massive MIMO working group, which has a standard development and activity in progress. And of course, applications and services working group has P1950 on smart cities framework that is also in progress. The information you can expect to see when you download a copy of the 2025 edition includes a treatment of the business aspects, such as business ecosystems and products and services. So what we do is look at this from a supply chain perspective, where we look at the source to consumption and develop different ecosystem stages with the intent to be able to look at how best to look at tracking the different types of information and what types of networks are best suited for those related products and services. So we are network agnostic. We look at cellular, satellites, Wi-Fi, fiber, and so on. We care really about 4 different perspectives, and that essentially is looking at this from an access point of view. We're looking at this from a service delivery, an operations and management perspective, as well as an interoperability perspective as well. You can see different discussions about Wi-Fi, 5G, and 6G. And obviously that is a work in progress, but there are some information already available there. The governance aspects also includes a discussion about time. We're looking at 3, 5, and 10-year road perspective. So a long-term view would be a strategic perspective. Tactical would be looking at near-term pilots or maybe a response type of scenario. And a day-to-day operations perspective is also offered. Digging a little deeper, we look at each one of the ecosystems, break it up into different stages, as you can see there. In this case, we frame the healthcare aspect as really about a continuum of care, anywhere from being needing some sort of remote assistance, monitoring assistance that is, or maybe you're looking at a more robust hospital setting, or maybe a long-term personalized type of care. So we treat that differently, break that up differently, look at the different types of networks, technologies and enablers that can help that is best suited for that. And of course, we're looking at this also from a deployments perspective with a view towards governance. So the details are obviously going to be in the edition. We also look at several scenarios, and I'll very briefly go over some of them. So we have an agriculture white paper from a related group. We take that paper, we look at this from a roadmap point of view, again, 3, 5, 10 years, looking at this from a food supply chain, climate change perspective, as well as a rural development perspective. There's also discussion about phase transportation and land repurposing areas. So it's kind of looking ahead in the sense of connected vehicles and what can be used and how can we kind of claw back some of the real estate and what can we do with that. So that's discussed there. There's a matter of pandemics and how can we anticipate that, as well as smart communities and rural development. Looking ahead, we are looking at this from some of the works in progress. Obviously, there's a lot of interest in 6G. So we are seeing the stages and the use cases that are developing for 3GPP. We take that we bring that into our transdisciplinary framework, and then we treat it accordingly by way of the different ecosystems. So we're also looking at different related groups, such as the P1950 and the transdisciplinary framework industry connections group, and looking at this from how can we stop certain pain points, how can we look at different opportunities for economic development, and so on. If this is an area of interest, and of course there's different applications here, feel free to download. These are separate works from different areas and different groups, but they're using the same general theme for the transdisciplinary framework, and of course they're available for download. If this is a group that you think that you want to get involved with, our information is shown there, the mailing list, if you wanted to contact us. And of course, if you want to reach out to me personally, my information is there as well. Thank you very much.
Hello, everyone. This is a recorded presentation of megahertz to terahertz networks working group. My name is Ramesh Gupta, and together with Tim Lee, we serve as co-chairs of INGR megahertz to terahertz networks working group. The objectives of this particular working group continues to be to examine improvements in current systems, network architectures, RF hardware capabilities, and signal processing techniques to enable current and future 5G, 6G systems. On the right, you see a report that was published under the title Millimeter Wave and Signal Processing Working Group in 2023. Since that time, starting from January 1, 2025, the group was renamed as megahertz to terahertz networking group, just to give it a more inclusive and broader scope, as the deployment of 5G hardware has already started for midband, and focus is shifting towards 6G developments. The key trends that we are noticing and where we are planning to focus during 2025 and continuing on are mid-band non-terrestrial networks, emerging Wi-Fi standards and beyond, autonomous vehicles, which are called V2X networks, and that's our main focus. As you know, all the iPhone 16 models in US, they offer millimeter wave capability, but the phones in other countries are limited to sub 6 gigahertz 5G bands, and that's because the millimeter wave growth, as I will be showing you, it has not taken off as it was projected. So in terms of 5G and 6G development, there has been a rapid expansion, and these charts, they show that a rapid growth, and the projections at this point are that more than 80% of the services will be available through 5G standards by 2028 to 2030 timeframe. And we are expected to reach by end of 2025 1.6 billion users. Here we show the use of low, middle, and upper mid bands for 5G, 6G applications. We talk about FR1, FR2, FR3, and there's a lot of activity today in FR1 frequency range, which is up to 6 gigahertz. The FR2 millimeter wave has not taken off as much, but FR3 frequencies, which are from 6 gigahertz to 28 gigahertz, those are the most attractive at this particular point for major applications. On the right, I show the a system concept and a reference. This is where we expect in the immediate future maximum growth to be taking place in the networks, and in future, of course, there will be emphasis on 6G options. In summary, I'd like to define the future focus, where we see growth in 5G NTN networks at FR1 in next 3 years, and 6G network development deployment in sub-terahertz bands in next 3 to 5 years. AI, machine learning, ML based system on chip designs in next 2 to 5 years. We believe low-cost packaging, measurements, and low-cost device fabrication challenges must be overcome for 5G and 6G deployments. The technologies that will come into focus are the reconfigurable intelligent surfaces, RIS, wireless power transfer, and the areas of applications are integrated, hyper-reliable, low latency communications, integrated and sensing networks for vehicle pedestrian detection, environment monitoring, usage scenarios for ubiquitous connectivity, megahertz technology for networking with other systems for rural, remote, and low density population, and for also interspace communication. And that concludes my presentation. Thank you.
I'm Giovanni Giambeni, University of Siena, the co-chair of the Satellite Working Group. I am very pleased to present the chapter that we have made this year. Okay, so first of all, I have to say that terrestrial network cannot guarantee coverage in areas like in the sea, in remote areas, and for aircraft. So there is the need of satellite system, and in broad sense, non-terrestrial network, including also IoT platform and unmanned aerial vehicles. This NTN system will also provide support for IoT and machine-to-machine communications, and will be integral part of 3GPP standardization starting from releases 17 and 18. This satellite chapter deals with the challenges and solutions that NTN system will need to address in the coming years. So our working group chair is Dr. Sastricota, I'm co-chair Giovanni Giambeni. Our members are more than 50 countries involved are almost as many, and with the broad coverage of different continents. You see here the web page where you have our material and all the information we have in bi-weekly meetings. And if you need to contact us, you have here our addresses. So this year, the report is addressing many important topics from physical layer, antenna design, artificial intelligence, edge processing. And in particular, we have a novel part on architecture, including on-RAN antennas for user terminal, routing, and standardization. So Mega LEO system have an impressive performance and are almost close to the performance of terrestrial system. As you see here, these data are related to download, upload, and latency for one Mega LEO system. And these performance are referring to US are also improving now. And in general, you see here minimum and maximum download, upload, and latency in last year still for this same system that are quite important and comparable with terrestrial system. So in this activity, in particular, I would like to show you the advance made with routing protocol. We have proposed a protocol for Mega LEO based on IS routing, adopting MPLS on the forwarding plane, and where we can use the predictable LEO motion to recompute routing updates, thus avoiding buffering. And you have here more detail. So let me conclude this quick overview, telling you that we address different use cases for integrating terrestrial and satellite. Our main concern is interoperability, and we consider that Open RAN can have a big role here, including the importance of virtualization, softwareization, and the use of Vetsimano orchestrator. Security principles have been particularly addressed, including post-quantum cryptography, quantum key distribution, and we believe that edge computing on satellite can provide an incredible new potentiality, including the capability of having G0B on board and UPF functionalities on board. Thank you very much for your attention.
Hello, everyone. My name is Mehmet Ulema. Alex Gelman is with me here. We are the co-chairs of the Standardization Building Blocks Working Group.
This is the team for the Standardization Building Block chapter. The mission of the working group is to support the technology groups, produce its own autonomous chapter about standardization, and to identify standardization opportunities for IEEE and emerging technologies. With every new generation of wireless networks, new technologies come into the picture. With the technologies come new stakeholders, new standards development organizations, and new alliances.
So as far as the new chapter on standardization building block is concerned, there are the four major sections. First section is basically organization, alliances, and open source organizations. The second major section is to address the challenges of cross standard organization collaborations. And the third section is to describe the challenges in standardization of emerging technologies. And finally, the last section is to explain our approach to standardization of emerging technologies.
This slide is a guide to additions to the chapter. This slide explains the technology evolution paradigm. We simplistically split it into four stages: conceptual, pre-competitive, competitive, and deployment. Shows the relevance and intellectual property strengths of the research and development output. In the very beginning, the strength of intellectual property is very high. If you write early papers, they're highly cited. If you write early patents, the claims are very strong. But the relevance of these technologies may not be high, or may end up being zero at the end of this process, because not all will make it. Some will make it through the standards, or some will make it through the market. So this slide exactly shows that interest of researchers and interest of practitioners. Researchers jump the ship with time, and practitioners pick it up. IEEE products kind of range from the very beginning to the very end of this process. We have very early workshops where technologies in conceptual and very conceptual stage are discussed. Then come conferences. After conferences come publications. And then typically come market-driven standards. However, to pursue standardization of emerging technologies, you have to produce standards that drive markets, maybe even disrupt markets. So in here you can see in the red the paradigm that we are pursuing. So the ecosystem in IEEE for standardization of emerging technologies is rather complex, but that holistic approach is actually what gives us the strengths and gives us a unique position in standardization of emerging technologies. On the top, you see Standards Association. That's where the platform comes from. That's where the standardization process comes from. On the right, you see future directions and their initiatives. That's the beacon of IEEE. They identify new directions, bring them to fruition in our products, and graduate these initiatives into the societies. On the bottom, you see alliances in industry. On the left, you see our societies and councils, all our products and our rewards. All this is a necessary condition for standards developers who are researchers. Researchers are interested in personal credit, in discoverable and citable contributions, that we have to position IEEE in the very early stages of technology evolution. Examples of early stage standards are terms and definitions, frameworks, reference architectures, etc.
So this slide shows, some of the emerging technology standards that are produced through close collaboration with the technology initiatives under the Future Directions Committee.
So among our recommendations are to start the standardization as early as possible.
So thank you so much for listening to us. And if you want to know more about what we are doing here, please contact about these gentlemen here to get you involved in our activities.
Welcome to the INGR Systems Optimization Working Group. My name is Nanganai Chaparadze. I'm co-chairing this group together with the DLIP. I'm presenting the work of the System Working Group on the white paper we have produced, as well as the status of the roadmap chapter. The scope of the Systems Optimization Working Group consists of various topics that we are addressing in regard to modeling control of complex networks of self-organizing and self-managing systems, especially looking at the problems regarding the control strategies that need to be applied for various kind of use cases and scenarios. And collaboration with the industry. We do collaborate with the industry and standards communities in particular in terms of shaping the roadmap, especially considering the growing trend on the topic of autonomous networking roadmaps and standards and architectures, especially considering that we look at what sort of gaps are existing in the standards in order that we can close the gaps in standards and also address certain research challenges. We do cooperate with the other INGR groups, namely AI, ML, energy efficiency, security, standards building blocks, and test-based working group. The roadmap chapter is available on this URL, as well as the previous versions and future versions are available as well on that URL. In terms of the landscape, future landscape, we are driven by various drivers in terms of the work of shaping the roadmap on system optimization, looking at, for example, the growing trend on AI infrastructures and networks that support AI apps, that need to support AI apps and workloads, and then the aspect of AI in networks through autonomous networking principles, and other topics that pertain to use of machine-to-machine communications applications in networks that need to support the M2M, as well as network disaggregation as a growing trend and associated architectures and optimization trends, the challenges of optimization when it comes to the disaggregated networks. Then comes the distribution of intelligent and autonomous networking paradigms and principles. And again, within the 10-year projection, we are looking at a future consisting of fabrics for compute intelligence and connectivity at various levels. And therefore, of course, the various fabrics, how to combine them, how to optimize them, becomes an optimization challenge that needs various solutions and techniques for optimization. And also considering a real-time discovery and peering of heterogeneous resources from different kind of providers of these resources, and negotiations and point of attachments between different kind of entities. Then self-optimizing techniques for autonomous networks behavior is also within the scope of looking at what the future looks like in the 10-year time frame. Then, of course, the discovery, auto-discovery, supporting techniques for auto-discovery and allocation of resources, and monetization of resources across different boundaries and domains of ownership, self-organization of federated domains, and across boundaries, private and public. These are some of the challenges that we look at within the time frame for the 10-year time frame that need to be addressed by the community. And in terms of strategy, we do cooperate with the different SDOs on alignment with the standards, especially with the ETSI regarding the Ghana framework as the reference model for multi-layer autonomic management and control, and multi-layer AI and supporting use cases for multi-layer autonomic management and control, and also the AN framework from the TM Forum Autonomous Networking, so multi-layer aspects of AI and ML use cases. We also collaborate with the NIST Public Working Group on multi-domain knowledge planes for service federation for 5G and beyond. In particular, we provide the systems optimization chapter for use in deriving requirements that need to be addressed in the architecture for federation using knowledge planes that automate the management and control of networks with using knowledge planes as the brain for management and control. The SysOpt has published a white paper. It's not yet published, but it will soon be published, but it has produced a white paper on common operational principles for autonomous networks. It's a requirement from the industry. It's a standard requirement. It's really requiring a standard by the industry to be produced on the common operational principles called Copan blueprint. So a standard needs to be developed, especially regarding the governance and federation interfaces for autonomous networking. This is what we are considering. We are driving this white paper together with TM Forum and other SDOs in what is called the multi-SDO that brings all the SDOs working on autonomous networking. And of particular interest in the Copan blueprint is the interfaces governance and the federation, and how to model the actors on each of the interfaces, as well as the primitives that need to be supported by the standard. And for example, this kind of primitives that need to be supported on the interfaces. Looking forward in the future, we are considering that the chapter will be evolved with other aspects that include, of course, the continued work on model boundaries and intent modeling and meta models. Also, the use cases for ML, especially applying digital twins and end-to-end federation and optimization across network domains, access, transport, and core. And of course, the self-X supported on all the end-to-end network segments. Then knowledge planes, use of knowledge planes in peering resources, and of course the knowledge planes as the anchors for federation and management and control for networks, intelligent management. In terms of joining the group, this is the site for the group. You are welcome to join. We invite all to join the working group. Thank you.